When chemical reactions happen, there's always the same amount of stuff, the same amount of matter at the end that there was at the start. So this is called the law of conservation of mass. Mass is never created or destroyed in chemical reactions, unless they're nuclear reactions, but we won't go into that. So I've got a couple of examples here of chemical reactions. The first one here is a methane molecule. In fact, it's combusting, it's burning in oxygen. So I have one methane molecule, it's one carbon atom with 4 hydrogen atoms. It reacts with oxygen. So oxygen molecules, this is one oxygen molecule, it's got 2 oxygen atoms here. And then it forms, so these 2 molecules form one carbon dioxide molecule. Again, 1 carbon, and there's 2 oxygens here, and it actually forms 2 water molecules. Now, really importantly, if we have a bit of a count here, if we count the number of carbon atoms which were on the reactant side, so there's 1 carbon over here, and how many carbons over there, are there over here? Well, there's 1. And we count how many hydrogen atoms there are. So originally in the reactants, there was 1, 2, 3, 4 hydrogen atoms. And over here is the products. Again, how many are there? 1, 2, 3, 4. So again, 4 hydrogen atoms to start with and 4 at the end. And we'll also count the number of oxygen atoms. So 1, 2, 3, 4 oxygen atoms. And over here, 1, 2, 3, and 4. So this is the law of conservation of mass. There's always the exact same number of atoms on one side of a chemical reaction as there are on the other side of the chemical reaction. I'll give you another example here. And this is, I've got hydrogen here again, and I've got hydrogen joining with oxygen. Hydrogen exists in our atmosphere, or as a gas. It exists as molecules of 2 hydrogen atoms joined together, and oxygen is the same. So if we add hydrogen to oxygen, we're always going to get oxygen in molecules of 2 and hydrogen atoms in molecules of 2. So there's 2 hydrogen atoms here, 2 oxygen atoms here. If these react together, I get H, and there's 2 of them, so H2 and O. Now straight away you can see there's a problem here. There's only 1 oxygen on the product side, and there's 2 on the reactant side. So this is not really accurate about what happens. So what we need to do is we need to, there needs to be more atoms. So on this side there's actually 2 molecules of water that are created in this reaction, not just 1. But then of course if you add all these things up, there's another problem. So 2 means there's 2 oxygens, okay, that's fine, 2 oxygens over here, that's fine, but now we've got 1, 2, 3, 4 hydrogens and only 2 hydrogens over here. So of course what really happens in this reaction, and this is the law of conservation of mass, there must be the same amount at the start and the same amount at the end. We actually start with 2 hydrogen molecules plus 1 oxygen molecule goes to 2 molecules of water. And that always happens in all chemical reactions all around the universe.